Welcome back to the second video on the Titan-1M, where we're going to get rid of this piece on the bottom here. We do that by literally flipping the part in the vise on the mill, just like that, and the bottom now becomes the top. To begin, we need to work on the orientation. But to not confuse anything, what we're going to do is we're going to rename this to OP-1. So I'm just going to click on it, single click again, and just type in OP-1. And then I'm going to click on the arrow and collapse it so we don't see it anymore. Also going to turn the model back on so that we can see our model. Next, we're going to click on New Setup, and that's going to be our OP-2. And we'll rename that one later. So, now that we've got the dialog box open here, we can see that the orientation is all wrong. And so what we're going to do is we're going to come down to Orientation, and we're going to change this to Select Z and X-axis, just like we did before. It wants us to select the Z-axis first. I'm just going to click on one of the vertical lines, and it wants us to select the X-axis. I'm going to click one of these, and they're pointing the wrong way, so let's flip the Z, and there we go. We got X, Y, and Z going the right direction. We also need to move it to the correct corner. Now, in OP-1, we started off with raw stock, and we used the upper left corner, which was this one here, to be our origin. But now that we have a partially complete object, we've machined the side all the way around, and those sides are an accurate place to set our origin. We also have this one machined and it's accurate. So we're going to set it to those three faces. So I'm going to click on Origin here, and I'm going to change this to a model box point, and then I'm going to select this one here, the lower left upper corner. And we're going to click on there, and that is going to give us what we need, because we can reference this machine side with our probe, this side with our probe, and we can measure off the height where the bottom is sitting. So it's going to give us a very accurate corner. So when we go to chamfer the rectangle, it's going to be accurate. Next, we're going to move over to our stock tab, and we're going to need to do the same thing as we did before. We're going to set the mode to fixed size box. We're going to set the width to 4.125, centered. Depth is 2-inch, centered. But what's different this time around is the height. We started with a 1-inch piece of material, but we've removed 20 thousandths off when we were holding it in the vise, and we machined the top off. So what we're going to do now is we're just going to enter that in. We're going to do 1 inch minus 0.02, and that is the current thickness. However, if we look like this, we know that there's no material down here, because we machined all that away. So we need to change our model position from center, and we want to set it to offset from bottom, and we're going to enter an offset of 0 because there's no material down there. And there we have it. We've got our stock set up, we've got our X, Y, and Z set up, and our origin set up. So we can go ahead and hit OK, and now we're ready to set up our machining tool paths. if we were to look at our actual part, there wouldn't be any material on the sides, but we can't really show that right now. So we just have to imagine that there's nothing on the sides, it's just the top, and we call that the hat. It's quite thick. We could fly cut it, but we'd be sitting there for hours, well, not hours, but quite a while with the watching the fly cutter go back and forth. It's not an efficient way to do this. So what we're going to do is we are going to set up a 2D adaptive clearing, leaving 10 thou, and then we're going to come in with the fly cutter and remove that last 10 and get that beautiful Superfly fly cutter finish. So we're going to go up and we're going to go to 2D, 2D adaptive clearing, and it brings up our 2D adaptive dialog box. I'm just going to pull it out here so we can see all the text down the side. Okay, so now we're going to select our first tool for the adaptive clearing, and we're going to go to Cloud, we're going to go to Aluminum. This time we're going to use a different tool, and we're going to do the Shear Hog Tool 8. The Shear Hog is a special tool. It was made for the Tormach. It's a single point carbide insert specifically made for aluminum. It allows super fast material removal rates, and it's ideal for this type of situation. It's 3/4 inch in diameter, so it'll make quick work of this hat. So now that we've got our tool there, we can continue through our tabs. Next tab is geometry, and all we need to do is just, with the 2D adaptive for this, just click on the top. That's all it needs. Click on heights. Since we're dealing with raw stock on the top, I'm going to use stock top for everything, and for our bottom height I'm still going to use model top on that. So 0.4, 0.2, 0.1, and 0. So next we'll move to the passes tab. It's just roughing, so tolerance is okay. Our optimal load, we're going to use our formula like before. Diameter of tool, 0.75 times 0.2. It's going to give us a 20 thou depth of cut. Or not 20 thou, sorry, 20% depth of cut. Our minimum cutting radius, 0.75. Good. Good. No multiple depths. We don't need to on this one because the material is about 1/4 inch to remove, and this shear hog will do almost a 1/2 inch. But our stock to leave, radial stock is, we're just going to set that one to 0 because that's stock around the outside. But we're going to leave 0.01, 10 thou on the top here to remove later with the fly cutter to get that beautiful finish. We're going to skip the multi-axis. We're going to go to linking. We're going to set our stay down percent to 70. We're going to set our lift height to 0. Our non-engagement feed rate is going to be set to 80 again. Time is money. Horizontal lead in and lead out is going to be set to 0.15. And we don't need to ramp. We can plunge because it will plunge on the outside of the part where there's no material and then feed into the part. Ramp clearance set to 1. And we're going to set a preferred lead-in position as per usual. Just click on the front here so that it will go where we can see it. I'm going to click OK, let it do its thing, and there we go. Exactly what I want to see. It's going to come down outside and then move in, and it's going to cut that top, most of that hat off. So we can simulate it and watch it. It moves in, it starts cutting, taking that nice big chip that it can do, and remove the excess. Much faster than using a Superfly and more efficient. And it makes a really cool sound when it's machining. So a few more passes. The other reason why this is not a finishing pass is the surface finish sucks, and sometimes it leaves the tiniest little bit of what we call an island on the part. So as it goes around, that's an island now. It gets thinner and thinner, and sometimes leaves a little tiny thin piece like that, even though it visually looks like it's gone. In reality, it'll be there. So that's good. We'll exit the simulation and we'll save. Hit OK. Also take this time just to quickly rename this OP-2. All right. Now it's time to set up a facing operation and clean that off just like we did before. We'll do that same way, 2D, and we're going to do face. We're going to change our tool to the cloud, aluminum, and Superfly cutter and select. We're going to move over to the face dialog box. We don't need to change anything in the feeds and speeds. We're going to go to geometry. It already recognizes that everything is there. We're going to go to heights, and we're still dealing with stock. So we'll use stock top, and model top, 0.4, 0.2, 0.1. And that looks good there. We're going to click on the passes tab, and tolerance is good for 10,000ths. We're going to make sure that it's a single pass, no multiple depths checked. Everything looks good, so we're going to hit OK. And now it looks good. So if we simulate it, hit play, it's going to remove that last 10,000ths that the shear hog left behind, and now we've got a nice, beautifully cleaned and surfaces part. So we can exit simulation, and that's good. Now we need to chamfer the edges. Remember that this material, this excess material on the side, is not there anymore. It just looks like it because we can't actually program the stock the way it looks from OP-1 job. I mean, we could draw it, but that would be a lot of work for nothing. We'll show you how to deal with that. So for now, what we're going to do is go to 2D, and we're going to go 2D chamfer. And we're going to go to Tool, Cloud Aluminum, and pick Tool 1, just like before. Hit Select. Our settings here are all good except for cutting. Remember, we want to slow that down because it's hard on tools. The tips of these things. We're going to click Geometry. We're going to click on the outside edge of our part. I'm going to go to heights, change everything to model top, like we did before. Point 4, 0.2, 0.1, and then our top height is a model top 0, bottom height model top 0. That way it won't go any farther than that model top. Go to passes, and we want to make sure that we set this. So chamfer width, we want a 10,000 chamfer width. We're going to change our offset to 0.05 and our clearance to 0. In the linking tab, we are going to set the horizontal lead-in radius to 0.025, our lead-in angle to 45, and I think that is it. So we can hit OK, and we can hit simulate, and hit play. And of course it looks like a huge chamfer, but it's not, because none of this material, this green stuff, exists. It's just doing the edge right there. And if we remove model, it's just taking a little bit off. It'll make sense in a moment. So I'm telling you everything's good. We'll hit exit simulation and we'll save. Alright, so now what we'll do is, as this was the last operation and the last tool of that operation, the part is essentially done. What would it look like if we properly simulated it with the actual tool or part visualized here? And that's what I'm going to teach you how to do now. This is a really cool thing we can do. So what we're going to do is we're going to left click up here on OP-2, and we're going to right click, and we're going to go to simulate. Now it just looks like a big block of stock, but what we can do is we can right click on this, and now it looks different because we're simulating it. Right click brings up simulation options. We're going to go to stock, and we're going to load stock. Remember how we saved that stock at the end of OP1? So let's click on it, hit select, and now it appears the way we machined it. So now we can see the actual hat here, the sides that are all clean and machined, and it looks pretty cool. So what we can do now is simulate it and see exactly what it would look like. So there's the shear hog removing all that excessive amount of material from the hat. Going around, I'm just going to scrub up to near the end. Very nice. Now the fly cutter comes down and cleans off that last bit of material. That beautiful finish. And now for the chamfer tool. And now the chamfer tool actually looks proper. Let's just click the model off and zoom in. And that's a perfect chamfer there. Now in order to get that perfect chamfer, of course, we need to have this X, Y, and Z in the right spot, and which is that corner, as well as we have to make sure we load this part in the mill accurately as well. But that's it. That's how you machine setup and for machining of OP-2. And once you've run your part in the mill, you're going to have that Titan-1M all done and dusted. So thanks for watching, and we'll see you on the next one.